All right, just give me 1 second. All right. Just gotta make sure my group or my roommate doesn't talk. All right, so our group was the precision launcher, and my name is Zachary Perry, and my group mates were Ryan Graf, Bo Smith, and Tyson Adams. So to begin with, the materials that we used to build our product was mainly scrap wood from my house, and what we most of our budget was spent on the hyper rocket, which was our main energy transfer, which was air pressure. So that was the best product we thought we could spend on to achieve this. And other materials that we used were the table saw, the impact driver, uh, fishing string, which was a strong, we had to have strong string to hold up our weight, triangle protractors, PCP pipes, elbow hinges, which was useful for connecting our wooden pieces, and etc. So how our launcher actually works is we simply just drop a 5 pound weight on the air compressed cushion, and this would transfer the air pressure to the tip of the launcher, which would shoot the projectile. And to make sure that we had the proper angle, we use rubber bands to hold up the front of the projectile, and we could use that to change the angle and ensure that we were getting the proper distance to our target.
So for our design, we made something that would hold a product called the Hyper Rocket. We bought a PVC pipe to go through the front end of the launcher and used rubber bands and nails to hold the product at different angles to get different results so that we could get a certain distance and a certain accurate certain type of accuracy. We also decided to add a sort of guillotine to the back so that it could drop the weight so that we would have more than one energy transfer because other than if we just drop the weight, it's like us kind of dropping it, but having the guillotine in the back made us get another energy transfer. Some design pitfalls: getting the weight to drop consistently was difficult because with the guillotine, it didn't always go in the same spot because it was still being pulled down by a person and the weight wasn't held in on both sides. And during the test, we saw that the rocket does not spin enough sometimes and it'll fall mid flight. After multiple uses, the cushion also becomes less effective at energy transformation, hindering the flight of the projectile.
So here's how we use the engineering design process. So our initial design was using was so we initially came up with the idea of using a trebuchet for our projectile launcher. We made all of our drawings and we began building it. However, we encountered some issues. We had a hard time building a stable frame. There was an inconsistent release point from the sling, so it was very hard to predict where the ball was going to go, and it had a high probability of breaking apart due to the large amount of force that we were putting on the arm. So because of all these issues, we had to redesign the project and we made it so it could use compressed air from a cushion. Some pros that this had was that it had a more consistent release point and we had much better ideas for how to construct the frame. However, an issue that this had is that it was pretty hard to aim and control the flight path still, but our projectile was switched to a rocket which we made spin, which made it go a lot straighter so it was easier to control. And to ensure we hit the target, we adjusted the drop height and the angle of the launcher.
For our Fed Day results, unfortunately, we were not able to make the podium. However, we were able to hit the outer ring of the target 2 out of 3 times, giving us a total score of 10 points. If we had more time to test and calibrate the project before Fed Day, we believe that we could have hit the target all 3 times. And if we had focused more on the precision of our projectile instead of the range, we would have been able to have more accurate and precise launches. If we could change anything about our project, we would try to get to the wood shop as early as possible and get a jump start on our first prototype. Furthermore, we would have looked at making sure our project was more precise instead of launching it further. Finally, we would have tested our project more and taken more measurements to get the exact locations of our project's target.
Some advice for freshmen is that when going into the project, you should start as soon as possible so that you're able to test way before Fed Day, because if one of your designs doesn't work, you're able to go in and fix it or completely make a new design. Communicate with your teammates a lot during the design phase, especially if you're trying to use the wood shop, because you have to reserve times and they fill up pretty quickly. Don't just focus on distance, because the more accurate you are, the more points you'll get on Fed Day. And also try to get to Fed Day a bit early, because you should test out your project as many times as you can so that when you're called on, you know exactly where to place it so it can perform its best. Here are some videos that we had while making our project. And this